Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We are a meetup group, and every Wednesday we either have an online or an in-person session. Tonight we're online, and on the first week of every month we try to cater for absolute beginners. So that's tonight. We'll be looking at some very introductory concepts. And so hopefully people who've never seen Python before can get going and have a bit of fun with it. The next 2 weeks after this week will be more looking at machine learning topics with Arun Prakash, and the following week after that, on August the 23rd, is an in-person session at Brisbane Business Hub. So make sure you RSVP to that if you want to come along. We'll got pizza beforehand, and there'll be a machine learning session, and also at the beginning of the night, while people are having pizza, I'll also help anyone who wants to try installing Python on their computers. So that's, if you're an absolute beginner, that's probably a worthwhile thing to come along. If you're having any trouble installing Python, I can help you through that. Okay, so tonight we're going to use Google Colab, which means that you don't need to have Python installed on your computer. You just need an internet connection and a Google account. And so if you look down below the video, or if you look at the meetup site, you'll see there's a link here to a Google Colab notebook. So if you click on that link, that'll take you off to a new tab, and where you can have you can view the notebook. So I should say that one of the advantages of these sessions, we're doing them live streaming, so you can ask questions. I'll be listening on the YouTube chat or on Slack, and if you there's instructions below the video as how to get connected to the Slack channel by sending an email to skypyproject@gmail.com. And send the questions into Learning to Code channel as part of Beginners Python and Machine Learning. So you can send it on YouTube chat. It's just YouTube chat tends to censor a lot of things, so the questions sometimes don't get through. Alright, so this is what Google Colab looks like. The very first thing you'll want to do is do a copy to drive, because you'll see here it says changes will not be saved. So if you make any changes, you won't be able to save them, but if you copy them to your own drive, then you'll be able to make changes. So if I click on copy to drive, it opens a new tab, and it'll have the word copy of Meetup 188, Tim, beginners lists and dicts, and that'll be saved. Anytime you go back to Google Colab and you're in your Google account, then you'll be able to pull up this notebook that you've and any changes that you've made to it. And if you really stuff it up, you can go back to the original and have a pristine version. Alright, now the first thing you want to do is connect to a new runtime, and by clicking on that, Google will set up a computer with you. It's a Linux computer running Python, and powering this notebook behind. You'll see it initializes it and gives it some RAM and disk space. Alright, so tonight we're going to be looking at, this is interactive Python. We'll be looking at a few data types like lists, tuples and dicts, and we'll do a bit of scripting of Python, looking at scripts, conditionals and loops. So a fair bit. We'll just touch on each one briefly, but we'll get to a stage where you can be writing little Python scripts yourself and having fun with this. Now Google Colab is made up of a series of cells. Each cell has got either text in it, like this one here, it's got formatted text. All of that's formatted text using Markdown. This is some more formatted text. Or we can have code cells, and if you hover in between any two of these cells, you can see you can insert another code cell or another text cell in there. So let's get started on the code cells. You can type in, this is some Python code. And so you don't have to type this because I've already typed it for you. The first line here, it starts with a hash, and the hash means we're going to define a list. Sorry, hash means it's a comment, and the comment I've got in there is define a list with square brackets and a comma separated list of any data types. Okay, so let's follow the comment. We'll create a list, so we'll get some square brackets, which we've got there, and then inside that we'll put different bits of data. So I've put in here a string, so that's some text with some double quotes around it. Could be single quotes, that'll work as well. I've got an integer, so that's a number without any decimal places. I've got a floating point number, and so that's a number that has got a decimal place. I've got another string which has got the digit 3 in it. I've got another string 210. Okay, so we've created this list of different data types, and we store that in a variable. We've called the variable LST, for short for list, and it's good not to call it LIST in this situation, because LIST is actually one of the built-in Python functions that you can use to create lists. So if you call your variable list, then you'll no longer have access to the Python built-in function. Okay, and then we're going to print the list. So there's our 2-line Python program, creates a list, stores it in a variable, and then prints it. So if I run that cell, it will do just that. So it stored it into a variable and printed that list, and the output comes out just below the code cell here. So you should be able to run that cell as well. Now I'm going to share this workbook as well with you, just in case I type anything in. Don't think I'm going to type too much in tonight, but if there's something new that's not in the original one, you can always copy that. Have a look at this one. So I'll copy this link and I'll send that off to YouTube chat. So hopefully you get that, and I'll also stick it in the Slack. So there it is in Slack. Oh, good. Looks like someone got it. Lorna says thanks. Okay, so what can we do with these lists? Well, they're 0 indexed, which means that we can refer to, we can use an index to refer to any element within the list, and the first one has index 0. So if I say list LST square brackets 0 square brackets, it will look through the list for the one with index 0, which is the first one, and display it. So, and that's the string SIX. And you can see it's, even though I created the string with double quotes, it's displaying it with single quotes because they are pretty much equivalent. Here there's just a couple of times when you swap between the two. Now the index you can use, like this is index 0, index 1, 2, 3, 4, 5, 6, or you can actually count back from the end. So if I go back 1, -1, that will refer to this element here, and -2 will refer to this element in the list. So let's test that out. I'll type LST -2, and it says 1, just as we expect. All right. So, give these things a go. Add in a new code cell yourself, and try to select a different element in the list. So type the list name and then square brackets to say that I'm going to use an index, and let's have a look at what's in index 2, and then click on the play button or press shift enter, and it says number 4 is at index value 2. Now you notice in the first cell here I use print to display list, and that's what you would normally do if you're using straight Python. But here we're using interactive Python, or IPython, as part of the Jupyter notebooks, and it can do a few extra things, and one of them is you don't have to put print if it's on the last line of a cell. You can just put a variable name and it will display whatever's in that variable as the last time, because it's quite a common thing that you'd want to do in a Jupyter notebook, and Google Colab is using Jupyter notebooks to provide this functionality. Okay. You'll also see it's got numbers here, so we can tell which cells have been run and which order they got run in, because you can actually run them in different orders, and it remembers stuff from cell to cell. So we created this variable LST in the first cell, and it remembered it here and here and here when we were referring to it. Okay, so the next thing we can do is find the length of this list. So we use the built-in function len, and then to call a function you use these parentheses, and you can pass in an argument, which we're going to pass in the value of the variable that we want to find the length of, and it's going to have a length of 7. So there are 7 elements in that list variable. Okay, so we've looked at how to refer to single elements using indexes. You can also use a slice, and a slice, you put in the starting element and you then put in the upper range, and it will include everything up to but not including that index. So 2:5 will give us 432. Now some people find it confusing. Why does it go up to but not include the final value? And there's a couple of reasons for that. One is that to know how many elements are going to be returned, you can just say, well, 5 minus 2 is going to give me 3 elements, and they are 432. So the way I think of the indexes is that the indexes actually occur between the elements, and that makes it easier to visualize what's going to be included when I include a slice. So if I've got my 7 elements here, you can think of index 0 as just before this first element, then index 1 is between the first and second element, index 2, index 3, index 4, index 5, index 6, index 7. So if I said give me what's at index 6, it'll give me 0. If I say what's at index 3, it'll give me the string 3. So if I say give me the slice from 2 to 5, it gives me everything that's between those two numbers, and that's what we got, 432. Similarly, the same thing will work with the negative indexes, so you can count back -1, -2, -3, and they will occur around just in between each of the data elements. So if you did a slice so from -2 to -5, in this case it would actually give you the same 3 values. All right. Okay, so I'm just going to remember what's in LST, and that's what we've got there. And now we're going to use this notation to assign an item to the value at index 2. So currently it's the digits 4.0, and we're going to say list2 we want to equal FOUR, and now tell us what list is after we've made that change. And here we go. Now you can see it's the same list, but this one element of the list has been replaced with from 4.0 to FOUR. You can delete an element from the list using the del keyword, and as you can see when you type in keywords, Google Colab colors it nicely, so we can see it's actually a keyword, del, and it'll delete what is in at index 4, which is TWO. So if we run this and then say, well, now what is our list look like, and we can see that we've no longer have this element here, TWO, that was at index 4. Okay, Lorna's asking 8 elements including 0. Okay, so I think that's for the length. So the length of list was 7, and that's including 0 is up to 6. It gives you 7 elements, and I think that's what you're asking. If you look at those indexes there, you see 0 up to 7. If you tried to call something at index 7, it will give you an index out of range error because there's nothing there. Okay. Now you can add things onto the end of an index. Here I'm going to add a value, which is a different data type totally. It's 1J. So does anyone know what 1J might represent? And there it is. It's just added it in. And I'll give you a clue for what 1J might be. If I say 1J times 1J and run that, it tells me that the answer is -1 plus 0J. So what J is the square root of -1. And so that's they call them complex numbers. Complex numbers have a real part and an imaginary part, and Python can handle them just natively, which is a very cool feature of Python. You don't get to use it much, but mathematicians love it. Okay, so that was lists. Now let's have a look at tuples, or tuples as some people say. So a tuple is like a list, except it is immutable. Immutable means you can't change it in place. So if we start, and you define it by using parentheses rather than square brackets. So if I've called my tuple TPL, you can call it anything you like, and that's my variable name, and I've just stored it in there. And if I print it out, it looks exactly the same as my list did before, except it's got these parentheses around it rather than square brackets. Like I can do indexes on them. So for example, tuple 0 gives me 6. Okay, now set a challenge here. What is something you can do in a list that you can't do with a tuple? And I've even left a blank square here, a cell, and you can even add a few more in there if you want, while you can experiment with some of the things that we did with lists before, and see if you can find something that that you can't do with a tuple that you could do with a list. So some of the things that we were doing, we were doing a negative index, and that seems to work all right. We did a slice 2 to 5. That's also working pretty well. Let's try a negative slice. And that gave us the same values, just coincidentally in this case. Now you notice that even though it's a tuple, we're using square brackets around the index. So a square bracket always means I want to refer to something by its index. If you use parentheses, it means I've got a function and I want to call it, which is not what we're trying to do here. Okay, we tried to delete an element out of the tuple, and there we go. We've got an error. Tuple object doesn't support item deletion, and that's because the tuple is immutable. I'll show you that word again, immutable, which means it can't be changed in place. So if you want to change what's in variable tuple TPL, you need to create a whole new variable and put it in there, or it can be as something that's, you can do an operation on this that returns a new value and store that new value into the variable. All right, now I've provided a solution here, and I'm using f strings. So if you've seen my episode on f strings, you'll understand what these are. And an f string is like a normal string, but I can have these curly braces in there, and inside the curly braces I can put any expression, and Python will evaluate the expression before it calculates the string and then prints it out. So if I run that, I'll say tuple 0 returns 6, tuple 1 returns 5. So indexing works, negative indexing works, the length command works, slicing works. Slicing, so this is slicing. If you want to say everything right from the beginning, you don't have to put 0 in there. You can just put a colon 4. You can even do from an index all the way to the end, and that's probably more useful because you actually don't know what the end index is. So 3 colon and then nothing will take you all the way to the end of the list. You can even use 2 colons in the slicing. I didn't demonstrate that before, but what that means, it means you're going to provide 3 numbers. The first one's going to be your starting number. Your second number is going to be the stop number, which will go up to but not including the stop number. And the third value is the step, and it's saying what you go up, how much you're going to step each time on the index, and that's saying I want to step in 2s, so I'm going 5, 3, 1. So you can see it's gone index 1, index 3, index 5. You can mix and match between positive and negative indices in your slicing. So this is saying I want to go from the start to number 1, but I want to go step in -1s. So because it's negative there, the start actually means the last place in the tuple and working backwards. So there we go, 0, 1, 2, 3, 4. Now if I tried to do assignment, that's one I didn't try above, that would have given me a type error saying it doesn't support item assignment. And the delete was the one that I showed of, which said it doesn't support item deletion. So both of those are actually trying to change the value of a tuple in place, and that's one of the rules. You can't do that, and there's reasons for that, and sometimes it's beneficial to have a variable that you know can't be changed in place, and so that if you can use a tuple, use a tuple, but if you do need to change it in place, then you use a list. And apart from that, they're identical. Okay, how can you convert between one to another? And this is that function that I mentioned before, list with parentheses. It's calling a function, and you just say, I want this tuple to be a list. So I put tuple into the list and I store it in a variable. And when I display that variable value, it shows the same values that we started with, but it's now enclosed in square brackets, and that means that we can make changes to it if we wanted in place. And to convert it back to a tuple, I use the tuple function, and so I put that data element into this tuple function, and it converts it. And you can do that with other data types as well. Like if you want to convert a variable into an integer, you use int. Into a floating point type, you use float, and if you want to convert it into a string, you just use str. All right, so that's a very brief look at lists and tuples, and now let's have a look at some programming, some scripts. So this is absolute beginners session, so any question is valid, and actually in our other sessions you can ask any questions as well, but you're absolutely not expected to know anything here. We're just trying to show you a few examples of coding. If you've seen other languages before, you might pick it up a bit faster than if you've never programmed before, so let me know if you're falling behind, because I can do this a bit slower if you are. All right, so we're going to look at the if statement, and the if is a way of making a decision in your code and deciding what you're going to do based on the outcome of some test. So you do a check of some kind, see and get a result, and based on that you can decide to do one of in this case 2 different actions. So what we're going to do is we're going to roll a die, so that'll give us a number between 1 and 6, and we're going to say whether the number is an even number or an odd number. Okay, so we're going to use if, and then we have some condition that evaluates to either true or false. And so if it evaluates to true, we do the first thing that's there. So we say if this is true, then print you rolled an even number. And then we got an else, which is basically if the first thing is false, then we can say, well, if it's not even, it must be odd. So you rolled an odd number. So the way that we are going to simulate a die roll is we're going to use the random standard library. So there's one of the standard library called random, but we have to import that library, otherwise Python doesn't know we're going to use it. And really the main reason for doing that is that there's so many different libraries and functions out there that if Python had direct access to all of them straight away, we'd certainly get some name clashes because different libraries would be using the same names for the same function for different functions. So we say, well, we do want to look at functions that are in the random library, and then if I import it this way with import random, then whenever I want to use a function that's there, I can say, I put the library name before it, random.randint. So I want to use the randint function in the random library, and randint returns a number between 1 and 6. And this is an interesting function. It's actually not very Pythonic, which means that it gives you a number between 1 and 6, and normally in Python the upper number is not included. So the Pythonic version is rand_range, which returns an int between 0 and 5 inclusive, which is very Pythonic, but it's confusing for rolling dice. So we're going to use randint, which is pretty much made for purpose. So it's going to give us an integer between 1 and 6 inclusive, and then we're going to do this operator with it, modulo 2, that it reads, and that just divides it by 2 and then finds the remainder. So the remainder is going to be either 0 or 1. If it's 0, it means you've got an even number. If it's 1, you've got an odd number. Okay, we've got a question here. Square brackets is index. Correct. Brackets or parentheses is for functions, yes. And curly brackets, yeah. So curly brackets we don't use next to a variable name. So this is square brackets that are next to a variable name. This is parentheses that are next to a function name. But we don't use curly brackets next to a variable name or function name. But we do use them for creating variables. So when you're creating a variable that we've used square brackets for creating lists, we used parentheses for creating tuples, and curly brackets we can use for creating dictionaries or sets, and we'll be looking at dictionaries later on tonight, so you'll get a chance to see curly brackets soon. All right, so let's run this cell and see how it goes. It says you rolled 3, which is an odd number. So you can see die roll is where I've stored this variable name. I divided it by 2 and it came up with 3 divided by 2 is one remainder 1. So the remainder is what modulo gives me. So 1 doesn't equal 0, so it's gone down to this line here, which is an odd number. Now if I run that cell again, it's given me a different one. This time I rolled a 1, which is odd. I rolled a 6, which is even. Okay, so you can just keep running that cell, and each time it'll tell you whether it's even or odd. Okay, so challenge 2, roll 2 dice and report whether the first die rolls a greater number than the second. Okay, So here's your chance to try some Python coding. Now we've already imported random, so we don't need to import it again. I'll just do some quick. I'll just create a variable here that'll store the first one. And I've got the answer down below, is another way of doing it. But I'll just try to show you different ways of doing these things, and you can choose which ones you like better. All right, so I've done 2 dice rolls, and I've got to report whether the first die roll a greater number than the second. Okay, so I can say if D1 is greater than D2, print. Maybe I should, I'll print them first. And I'll just do very simple commands here because save on typing. And we want to say, is the first number greater than the second? First greater. Okay. Else print first not greater. Okay, so that's really what it's asking, just a whether it's greater or not. So let's run this and see what we get. So we get 6, 1, first is greater. Run it again. 1, 5, first is not greater. 3, 2, first greater. 1, 4. 2, 1, first greater. 2, 6, first not greater. 3, 3, first not greater. Well, they're equal, but I mean, it is true, first is not greater than the second. But let's have a look at the solution, because that takes into account the situation that they could actually be equal. So let's have a look at the differences. First of all, it's storing both answers, both dice rolls in a list with the square brackets, and then it's referring to each one using square brackets to index them. So 0 is that one and 1 is that one. So I just used 2 variables up here and didn't use lists at all. Okay, then in my if statement I had if that's true, which is pretty much the same as my if statement here. I do this, and then I did else if. So this is another thing that you can put in an if statement. It's another keyword because it's in purple, elif, which means else if. The first roll is less than the second, and if it's not less than and it's not greater than, then they must be equal. So it prints they are both equal. So let's run it a few times and see how it goes. 3, 4, first is less than second. 1, 2, first is less than second. 1, 1, they are both equal. And 6, 5, first is greater than second. So it seems to work in all the cases that we've got here. You'll notice that up here it printed on 2 lines, and I managed here to print it on 1 line. And the way I've done that is in my print statement. At the end I did a comma, and then I said I want the end to be equal to a space, rather than, because the default is a new line. So every time you run print, by default it'll print a new line. But if you don't want to print a new line, then you can just say, well, make the end character a space rather than a new line, and it'll just leave a space there, and then in fact there's a space there, that's the one, and then it'll print the rest of any future print statement will happen on the same line. Okay, for an element of tuple, say whether it's a string or an int or other hint, check an element is a string using type equals string or is instance string. Type is used for the exact match of the class, and is instance is used for if it's a class or a subclass. Okay, so I'm going to use is instance this time because in the other solution I use type. All right, so we've got our tuple, element in tuple, print e. So let's just run that. So there, remember our elements in the tuple. Okay, so we've got to do a some tests on that. So we say if is instance e is an instance of string, print, I'll do print e again, and is a string. Okay, now we want to put another condition in, so we use elif is instance e comma int, and then we want to have a catch-all if none of those conditions are true. And I'm going to use an F string for this one. So I put an F out the front of the double quotes, I put some curly braces in the F strings. Oh, there's another place we're using curly braces, inside F strings. And in there it evaluates an expression and then displays the result of the expression. And the expression I'm going to do is call the function type and say find out what the type of E actually is. Okay. Sorry. Now I can get rid of that print statement there because I'm printing everywhere else. So we've got 6 is a string, 5 is an int, 4.0 is a float, and you see how it's printed that because that's what the output of the word function type is. 3 is a string, 2 is a string, 1 is a string, and 0 is a string. All right, so that's one way of doing it. Is probably the more preferable if you are doing testing, unless you need to do an explicit test, then you would use type because that gives you an exact match, and this one just will work on subclasses, which is a topic for another day. So there you go. All right, now we've done the for loop. I don't know if I told you about the for loop. No, I didn't. That is the first time you've seen a for loop. So a for loop is a way of going through a piece of code multiple times, and each time you set a variable with a different value, and it gets the list of values that it uses from whatever you put after the word in. So you say for variable in something that's iterable, they say. So it can be a list, it can be a tuple, it can be a string. You can define your own classes that have iterable properties, and then you can use them in for loops. And so the first time through the loop, it just takes the first value from that iterable thing. So in this case, it was the string 6. Second time through, it takes the second value, in this case 5, and it stores that value in variable e, which we can use everywhere through here. So sorry for glossing over that if that was the first time you've seen a for loop. But for loops are very clean in Python. It's very easy to read what is actually going on. So if I didn't have a for loop there, I would have had to refer to each element individually in the tuple. So for me to do that, I could do that. So the other thing I haven't really talked about is indentation, and it's really important in Python. Is Python uses indentation to work out what's in the code block. So in an if statement, you see the if statement ends in a colon. The colon basically says I'm about to start a code block. And then anything after it that's indented, and normally we indent by 4 places, but it doesn't have to be 4, but most Python programmers will do 4, then it is included in the code block. And then when you remove the indentation, the next line that's not in the code block is not indented, and that's how Python works it out. So white space is very important in Python. It makes it different to pretty much every other language, because other languages will use curly braces everywhere to tell you where your code blocks start and finish, like Java, JavaScript, C. They all use curly braces, but Python uses indentation to tell you where the code blocks start and finish. So all of these lines here are indented, and they're all part of the for loop. So the first line that's not indented will be back on the same, will be outside the for loop. So it's got to be indented the same amount as the beginning of the for. So if I had 2 print statements like this at the end, and I run this, you'll see that this print statement here runs every time through the for loop, but this one only runs once right at the end. So you can see I'm indented, I'm indented, I'm indented, I'm indented, I'm indented, and then this one I am not indented only runs once. Okay, programming. So we'll go for loops and while loops. Oh, I was going to actually show you how to do this without using a for loop, because at this stage we didn't actually know how to do it without a for loop. So what I would have had to have done, I could have done this. So not indented it, and then just gone e equals tuple 0, and then I could have done that again. Let's just get rid of all of that. E equals tuple 1, and then copy and paste. And really, when you start copying and pasting code, you know you're doing something wrong. That's when you should be looking at some other way, because you shouldn't be copying the same code in multiple places. So you can see here, tuple 0 is 6 SIX, and so I have to do all those if statements there, and then I have to do the same thing for tuple 1. So the loops make it a lot quicker to, you make much more concise code. It's much clearer, much easier to debug. Okay, and you can see how the for loop works. It repeats every item in an iterable sequence. So there's an example of a sequence, 3, 2, 1. So before we used a variable name here. This time we're actually going to write the sequence in literally, and then we can print the number. And print is indented, so it's the bit of the loop that gets repeated. There's also another loop called a while loop, and while works like for, except it's looking, well, it actually looks closer to how if works. So you put in an expression that resolves to true or false, and if it resolves to true, then it will run everything there. If it comes to false, then it jumps out of the while loop and goes to the end. So we can do the same code before, checking which one's greater or less, and we can do it 10 times. And each time we increase our counter by 1. And I could have done that. We use this instruction in Python, which is plus equals, means add this value here to the value in this variable counter and save the result in that same variable. So if you're going to use a while loop, you need something inside the loop that's going to change the value of this expression. Otherwise you will get an infinite loop. And in this case we're increasing counter, so eventually counter is going to be bigger than 10 and the while loop will stop. Okay, write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. Okay. So we've got a tuple, so that's good for a sequence. So we can say for n in all right, so what I'm going to have to do here, just using the things that you know, I'm going to have to use a while loop, and I'm going to set n to equal 0 first, and while n is less than the length of numbers, then I can print n, and I can print the value of numbers at index n, and I won't do the even or odd thing yet. We can do that later. And then I have to do something that's going to change this expression, otherwise we get an infinite loop. And so what I can do is I can increase the value of n by 1. Well, n is less than... and numbers is not defined because I didn't run it. So you can see, if you look at that cell above this one, it's got square brackets at the beginning with nothing in it. It means I haven't run it. So if I run it, and now I can run this one. There we go. So now I've got a number as a digit, and then I can convert it to words by looking up the nth index in that tuple. So I could have done that. Another way I could have done that is I could have done it as, let's create another one. No, you don't know how to do it in for loop yet. So, oh yes, you could do it in a for loop. You could go n equals 0 for n name in numbers, and that'll go through these 0, 1, 2, 3. Print n comma n name, and then increment n. And so the first time n equals 0, n name, it just takes the first name out of this, so we're getting the names as they come out, and then I print n and the name of n, and then I increment n, but n name gets incremented automatically by the for loop. So it's probably a little bit simpler code, but let's have a look to see an even better way of doing it. There's a built-in function called enumerate, which does exactly what we want. We want to go through the loop. We want to know a number that represents which time we've been through the loop, and we also want to get the value out of a list that we're iterating over. And so enumerate does that. It gives us all the values, which are these text values, and it gives us all the i's, which are the digits, and then we can print them out. And now we can do the second part of the task, which was say whether it's even or odd. So we just put an if else statement in there to calculate whether I is even or odd. And there we go. 0, 1 up to 20, 0, 1, 2, 3, even odd, even odd, even odd, even odd. All right, so let me know if there's any part of that you didn't understand. But you can see enumerate returns a pair of numbers every time, a pair of values every time. And so we've got a pair of values coming in. We can store those. We have to put two variable names here so that it can put the two values that it gets out of each loop, each time through the loop. So we put I and value there. And you can see I there, the I's, and you can see value. So in fact, what I should put there is value. I don't need to look it up in the index because I've already got it in value. So let's run that. There you go. That makes more sense. Otherwise I wasn't using value at all. Okay, so the problem with this code is it doesn't scale well. We could make a tuple with 100 elements for the numbers 0 to 99, or we could have 2 tuples, one for the first 20 numbers and one for the tens, and manufacture from them. But the problem is, if we want to say, if we've got I equals 30, the way to get to the value 30 there is we have to divide by 10 using integer division and then subtract 2 to get the right index. And that's not very obvious why we would do that. So is there a better way? And yes, dictionary is the better way of doing this. It stores values and indexes. And the indexes can be numbers, as we've got here, or they can be strings, or they can be anything that's immutable. So they can be tuples, because tuples, remember, are immutable. It can't be lists, because lists are mutable. All right. So let's run that. So if I say I is 30, then 10's I, it just returns the value 30. So it's a quick way of looking it up without having to make a really long list or tuple with the values in it. So that's using, these are called the keys and these are called the values in a dictionary. And the keys are most commonly integers or strings. So here's an example using strings for the keys. So for example, if we wanted to convert Python to the phonetic alphabet, then that would be Papa, Yankee, Tango, Hotel, Oscar, November. And we iterated using this for statement. You can actually iterate over the letters in a word and store the letter one at a time in variable letter, or whatever you want to call it, and then use that letter to look up the phonetic name, and then you can print that out, which is what we've done here. And we've done end equals space so that it all goes out on one line, and then we finish off with a print just so that it ends off the line. Okay, write a Python script to write a number in words for any number between 0 and 99. So remember, we've got the tens and we've got the numbers up to 20. So we've got these numbers here are stored in tens, and we've got these numbers here stored in numbers. So how can we put them together to get every number from 0 to 99? Okay. It says consider the following conditions. The number is less than 20, the number is greater than 20 and divisible by 10, or the number is greater than 20 and not divisible by 10. So let's try number, let's say number equals 57. So we say if number is less than or equal to 20, and you see how I've done less than or equal in Python. It's a little bit different to using the Unicode character there. I have to use, because Python doesn't recognize that character, you'd have to use the less than sign and the equals sign put together, and that gives you less than or equals. Print numbers index number. Okay. The next one, if it's divisible, if it's greater than 20, so I do else, but divisible by 10. So another condition. Divisible by 10, I use modulo. Remember, that works out the remainder when I divide by a number. And if that equals 0, then I know it's divisible by 10. So in that case, I'll print out tens of the number. All right, let's see how that goes. We'll try 50 to start with. So I put in 50 and it came out 50. Okay, that's good. Let's do 5. I put in 5 and it comes back with 5. So that's all working. what about if I put in 57? It doesn't print anything because neither of those conditions are true, so we have to put an else in. Else. Okay, so I need to work out, I need to choose something out of the tens and something out of numbers. So let's go n1 equals number so I'll divide it by 10 and get the remainder, and I'll get how much is going to go into the tens, and then I'll print tens and 10 followed by numbers n1. 57. So that's looking pretty good. It would be nice to get a dash in between the two. So, you know, I could put a dash between the two like that. But then if I do that, I'm going to have spaces around the dash. It's looking a bit sparse. So I have to set a condition on my print statement. One of the options is set the separator. I'll just set that to nothing. Okay, 57. So that works, and then I could just put any number between 0 and 99 in there. 99, that looks good. Let's try something multiple of 10. Yep, let's try 17. Yeah, it looks like it's working. Okay, so here's the code. Oh yeah, so if you wanted to do every number, I'd have to do a while loop to go through all those numbers and just check until I got up to 99. Or I could use this built-in function called range that says give me every integer from 0 up to, but not including the final number, and so that'll give me up to 0 to 99, which is 100 numbers, and then I can print each one of those values, and the rest of the code looks pretty similar to what I did. It used an F string, which I think is a better way of getting the dash in between the number of tens and the number of ones. Let's run that, and there we go. We can scroll on that, and we get all our answers. So in previous episodes of this, I've had exercises where we've taken it up to trillions. And so we've had, so if you want to exercise for the reader, that's another thing you can expand on this code to start. So you start with the numbers from 0 to 999. So see if you can get the hundreds into there. Anyway, so there you go. It's a fun little exercise. So that's all for tonight. I hope you enjoyed it. If you've got any more questions, final questions, you can ask right now, or if you're coming at this later and watching it later, you can ask on the YouTube, on the Slack. The YouTube chat won't be there. You could probably ask the question in the YouTube comments, and sometimes I get around to answering them. But these ones are good in the Slack because we can, other people can see them, and if I don't get a chance to answer it, someone else will. I hope you managed to get the things done. Run the exercises. Save it all in your area. You can come back later and have a look at them. Okay. Thank you very much for your time. Bye.